Shall I continue? Shall I continue? Shall we continue?
Yes, sir.
You have done up to length 1 meter. Next, we'll take portion, which is the portion CD. See, always you should remember whenever there is a moment or a point load, whenever there is a point load, there is a sudden jump in shear force diagram. Whenever there is a moment, there is sudden jump in bending moment diagram, which I will show you. Portion between x greater than or equal to 1 less than or equal to 1.5 portion. This is CD, segment CD. Okay, in the figure this would be looking like this: A, B, C, and section I'm taking it here somewhere in between x3, x3. You can call it x3, x3 or xx, or call it as xx. And there is a force 25 kilonewton, moment 57.5. Okay, 57.5, and UDL, which is of 9. I'll write the UDL like this only: 20. This is zero point 0.5. This is zero point 0.5. Okay, this is this. I can write the equivalent force as section x3 or x3 or xx, x3 x3 or xx. This is 25. This is point B. Load is equal to UDL is equal to W into X, which is equal to, which is acting at the center, which is equal to 10. This is 0.5. This is 0.5. This entire distance is from one end. I'm considering it's X. Okay. Now tell me, can I write, if this is X, okay, this is zero point 0.5, this is at the center, this UDL is, this entire length is zero point 0.5, from here to here it's 0.5. Therefore, I want the moment is, this force is 10, I want this distance. I want this distance for my moment. For my moment, isn't this distance is nothing but x minus, this is zero point 0.5, this is 0.25. Isn't this distance is equal to x minus 0.75? Right? This is zero point 0.5 plus this 0.25, which will be equal to 0.75. I will subtract this from the x 0.75. This distance from the centroid to this distance will be x minus 0.75. This distance is x minus 0.75. Okay, shear force is equal to summation of vertical forces, which is equal to, whenever there is only UDL, then the X terms comes in shear force, UDL or UL, the intersection. Therefore, towards the right of the suction, if this is the suction XX, force acting upwards is positive. This is positive. If this is the suction, force acting downwards and the left hand side is negative. Bending moment, this and this is positive, this and this is negative bending moment. Okay, now this is the suction, this is the suction, negative. Okay, so force, this is acting positive, this will be equal to 25. Force is equal to summation of forces, not moment, 25. Load is equal to, what is the load? Load is equal to, this is 10, 25, 20 into 0.5. This itself is the load, minus 10, minus 10. If the suction passes through in this region only, in this region, then you should take 10 into something that the text will come into picture. So what I will get at this region, what is the shear force at the next point, whatever is linearly varying. But see but in this region, when you go away from that, you will consider the force is nothing but entire force will come into picture. Whereas when you take a suction here, part of the force or some of the force, which I don't know the magnitude, will come into picture. Therefore, I will take in term of x. Okay, now it is 10 into when 10 into 20 into zero point 0.5, it's 10. Downward direction is negative. Okay, is there any other force? Also moment is acting like this. 57. This is equal to 25 minus 10, which is equal to 15 kilonewton in the shear force. Next, moment is equal to summation of moment over x, which is equal to 57.5. In this case, this is positive. This is the suction. This is the suction. It is acting like this. It is acting like this. Therefore, this should be minus 57.5, minus 57.5 counterclockwise direction. Okay, and load is acting like this. This is bending the suction like this positively, plus 25 into x. Okay, this is bending 10 kilonewton. 10 into this is 10. I will tell you this 10. This is bending the suction. This is bending the suction like this, like this, like this, which is negative. See here how I will take the term. This is minus 10 into this distance. I have to take minus 10 into 20. 20 into zero point 0.5 is 10. 10 into x minus 0.7, x minus 0.5. When there are two cases only, when the suction passes through on the UDL, when the suction passes away from the UDL. When the suction passes on the UDL, what I have done, I've taken on the UDL, this is zero point 0.5, then this will be x minus zero point 0.5. Then the half of this will be x minus zero point 0.5 by 2. This is one case. When the suction passes away from the UDL, like this, away from the UDL, I will subtract the distance 0.5 minus 0.25, therefore 0.75. This is the distance 0.75. Force into perpendicular distance I have taken this. Okay, next, moment at x is equal to, I have taken all the terms to check it out. Any term should not be confusion if I left out with any term. Okay. Moment about this ranges from 1 to 1.5. Moment about x is equal to 1, which is equal to minus 57.5 plus 25 minus 10 into 0.25. You tell me this value. Moment at x is equal to 1.5, which is equal to minus 57.5 plus 25 into, this is 1.5, 1.5 minus 10 into 0.77 to the fourth 7.5. This is 0.75. Tell me what are these values. What is moment about x is equal to 1? How much? How much, Abdul Razak? Dhruti? How much? At x is equal to 1? Mekala? How much? Ravindra? Why you are unable to calculate minus 57.5 plus 25 minus 10 into 0.25? Yes, tell me, Dhruti. Yes, tell me. Yes, what is your doubt, Dhruti? Tell me. How much?
Minus 35, sir.
Minus 35 at x is equal to 1, right?
Yes, sir.
At x is equal to 1.5. minus 35 at x is equal to 1.5 minus 27.5. Now, see there is a 25 10 into x minus 0.5. Give me a moment. Minus 27.5 plus 25 x 10 into x. Okay, there is only shear force is constant, bending moment is linear. Now we will go to the shear force diagram. Within the region 1 to 1.5, shear force is 15 kilonewton. This is 15 kilonewton. This is zero point 0.5, up to D. This is 15 kilonewton like this. Okay. From from uh, x is equal to 1 to 1.5, it ranges from minus 35 to minus 27.5. It's linear. Minus 35 to minus 27.5. It's linear. Minus 35 is this point. Point D at 1.5 distance. This is if you should indicate it here. 27.5. This is linear, like a straight line like this up to this point. Okay. Next. Next portion. See, you see here. Uh, when the bending moment in the bending moment diagram, when there is a we'll come to this at the point D, we got the moment as minus 27.5. Now we will see when there is a moment, when this moment is acting 20 kilonewton meter, there will be a sudden drop or rise in the bending moment. We'll look into that. Portion CD, x greater than or equal to 1.5, less than or equal to 2. Portion CD is over. CD na portion AB, BC, CD, DE. Portion D, segment D, right? Segment D. Next, I'll write the sketch. 25, 57.5, A, B, C, 20.5, this is point C, point D, there is a moment 20, and point E will not go up to this end. I will consider suction in between, somewhere in between. There is a suction here, x4, x4. This is the suction x, which is at a distance x from this end, which is at a distance x from this end. I will draw this once again. 25, 57.5. This force 20 into 0.5, it's 10. This is A, this is B, this is C, and then this is D. Here there is a moment 20 kilonewton meter, and this is suction x4, x4. Okay, and this distance is x. If this is x, if this is x, this is entire thing is zero point 0.5. This is also zero point 0.5. Okay, then this distance will be 0.25 from the centroid. Isn't this distance remains the same, x minus 0.75, perpendicular distance from further 10 kilonewton load, right? Now shear force F is equal to summation of vertical forces F of y, which is equal to force acting upwards is positive from the right hand section 25, okay, minus 10. This is energy force, no other force. This remains the same. Portion DE 15 kilonewton. Moment is equal to summation of moment about xx section xx, which is equal to 25. If I write like this, about section xx, this is positive. About section xx, this is negative bending moment. Okay, force is creating a moment like this, which is positive. Therefore 25 into x, 25 into x, and then this load which is at a distance of x minus zero point 0.7, this is 0.5, this is 0.25, the remaining distance is x minus 0.75. The x is whatever it might be, this is x minus 0.75. This is causing a moment like this is causing a moment like this, which is hogging. Therefore this is negative, minus 10 into x minus 0.75. Okay, and this moment, see, suction, this is towards left of the suction, this is clockwise, left of the suction, this is clockwise, sorry, suction is at the right side and the moment is clockwise. Suction in this is the case, suction is at the right side and the moment is clockwise. This will not come into picture because suction is towards the right side and the moment is clockwise. This is not the case. Suction is towards the right side and moment is clockwise, as in this case. This will get added up, that's 20. Okay, m at x is equal to 1.5, which is equal to 25 into 1.5 minus 10 into 0.75 plus 20. Tell me the value. Bending moment at x is equal to 2, which will be equal to 50 minus 10 into 1.25 plus 20. Tell me the value. Only 20 mark problem. One problem will be asked like one or two problems. What is the value?
57.5.
M at x is equal to 1.5, right?
Yes, sir.
Okay, okay. See, one more thing. You should, when I do this type of mistake, you should tell me. Okay. Always I forget this moment. There's a moment 57.5 acting. This is a section. There's a moment like acting like this. This is minus 57.5 plus minus 57.5 plus minus 57.5. Tell me the value. Yes, Ravindra.
M at x is equal to 2 is 0, sir.
X is equal to 2 is 0. Okay. X is equal to 1.5.
1 minute, sir.
Others, what are you doing? Lokesh? Lokesh.
So minus 7.5, sir.
Yes, minus 7.5. Minus 7. You should indicate, you write the unit kilonewton meter bending moment, kilonewton meter. Okay, all your should at force is equal to some 15 kilonewton. Now I'll go force remains the same 15 kilonewton. So in throughout the portion 1.5 to 2 length, it is 15 kilonewton. I will indicate D2. This is 1.5, this is zero point 0.5, 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 this is zero point 0.5. Throughout 1.5 to 2 is 15 kilonewton like this. Next, moment about x is equal to 1.5 is minus 7.5 and x is equal to 2 is 0. This is constant, this is linear. This is minus 7.5 and 0. Minus 7.5 will indicate, just simply indicate it like proportionally. 7.5, sorry, yeah, sorry, this see at x is equal to 1.5, this is minus, you can see a sudden drop. There is a sudden drop, it has come to sudden drop. There is a sudden drop, you can see here. It has, there is a sudden rise or fall. There is a sudden drop here up to 7.5. Okay, like this, it will go straight like this, and then from here 2 up to this point, it will become 0 like this. At this point, it is 0. Okay, can you see that? Or shall I write some? This is 20, 35, 27.5. Point is 27.5. This is linear. This, and there is a sudden drop up to 7.5, and then this becomes to 0 like this. Okay, you should indicate this is linear here. When shear force is constant, bending moment is linear. Shear force is constant, bending moment is linear. Shear force is linear, bending moment is quadratic. Shear force is constant, bending moment is linear. No load, shear force constant, bending moment linear. Constant load, shear force linear, bending moment quadratic. No load, shear force constant, bending moment linear. No load, shear force constant, bending moment linear. Similarly, no load, shear force constant, bending moment linear. Okay, this should come. Now, segment EF x greater than or equal to 0.5, 0.5, 1.5, less than or equal to 2. The right sketch 25, 57.5, B, C, 20 kilonewton per meter, point D, 20, point E, 15. My suction x5, x5 is here. Take the suction here, x5, x5. This is at a distance x, or I'll write the equivalent sketch of this x, x 25 to 7.5, A, B, C, D, 20, and at point T, I have managed to 15 kilonewton load. Okay, point T. Next, this is 20 kilonewton, 20 into 0.5. At the centroid, I have 10 kilonewton load. If this distance is x, this distance is x, this will be, this is 0.5, this will be 0.25, this distance will be x minus 0.75. Therefore, shear force is equal to sum of the vertical forces from one of the direction, which is equal to 25 acting upwards minus 10 minus 10 minus 15, which should put to 0. Always you should get 0 at the one of the other end. Okay, bending moment is equal to sum of moment about xx, which is equal to 25. This is bending the beam in this fashion, bending the beam in this fashion about this point x. You can also continue like this, which is a smiley face. 25, 25 into x. Okay, moment, this is it, this is the face, this is like this, like this is the moment, like this is the suction, this is the suction. This moment is this, if I take the suction here and this is the moment, this resembles the case like this, anti-clockwise. Therefore this is negative, this is positive smiley face, minus 57.5. Okay, this 10 kilonewton will also bend the face in this fashion, in this fashion about this point. This will bend the beam like this, about like this, 10, Okay, this is similar to this. Okay, therefore I have to take this as minus 10 into this distance, force into perpendicular distance for UDL, 10 into x minus 0.75. Okay, and then this section is towards the right hand side, and then the UDL is acting in the clockwise direction in the sense this is acting, this is clockwise direction, this is positive, plus 20, plus 20. Okay, and also there's a point load you should take properly, point load, which is I have taken this point load. Okay, point load, this is bending the beam like this, which is also hugging negative sign, minus 15 into x, this distance I want, force into perpendicular distance, 15 into x minus what is the distance, d to e, up to this distance 1 to x minus, right? This is zero point 0.5, 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 x minus 2. I want only this perpendicular distance. Therefore, x minus this entire this length will give this perpendicular distance. Therefore, m at x is equal to 1.5, which is equal to 25 into 1.5 minus 57.5 minus 10 into x minus, that is 0.75, plus 20 minus 15 into zero point 0.5. M at x is equal to 2, which is equal to 50 minus 57.5 minus 10 into 1.25 plus 20. Tell me the values. How much?
Minus 15
Minus 15 for what? M at x is
for
equal
1
to
point,
minus 15.
1.5.
Give me a moment, let me check. Mm, Minus 15. M at x is equal to 1.5 minus 15. Let me check it. Check it properly, Nicola. 25 x minus 10 into x minus 0.75 plus 20 minus 15 x. See, okay. You should remember me. I forgot this moment. 57.5. Okay. This is acting in counterclockwise direction. Minus 57.5. Subtract minus 57.5 from this equation. You tell me now. Minus, tell me now, Mekala. M at x is equal to 1.5 is equal to how much? M at x is equal to 2 is equal to how much? 1.5 how much?
Minus 72.5.
Correct nodi. I'm getting 0. X is equal to 2. 2, sorry, x is equal to 2 to 2.5. 0.5 to 2 to 2.5. Okay, 2 to 2.5. Sorry, x is 1.5 to 2.5. 2.5. Yes. I'm getting 0. At x is equal to 1.5 also 0. At x is equal to 2.5 also 0. Kindly check it. Minus 57.x plus 25x minus 50. Sorry, I have taken 57.12. Sorry, give me a moment. 25x minus 10 into x minus 7 plus 20 minus 15 into x minus 2 minus 15. See, you have gone wrong, Mekara. Somewhere you have gone wrong. Kindly check it. What I have written was correct. How much you're getting?
Sir, at x is
Raghavendra?
equals to we are getting 0, sir.
Both the
2.5.
case 1.5 and 2.50, right?
2.50, sir. 1.5 doing, sir.
Do it. You should start from 1.5 and you should go to 2.5. Regarding labs, Raghavendra, uh, I'm finding like there's no sufficient time for me to discuss now. Now you can call me later in the evening at 8 o'clock. Can you call me? 8:30. Can you call me? Raghavendra, are you there? Are any of you, any one
Yes,
of you
sir.
can call me? Okay, Raghavendra, call me at 8:30. I will tell you convey the same message to your friends also.
Okay, sir.
At x is equal to 1.5, how much you are getting? Zero? Yes. Raghavendra. How much? 25 into 1.5 minus 10 into ಎಷ್ಟು ತಗೊಳ್ತೀರಪ್ಪ 10 into x minus 0.75. Shall I write 0? Shall I write 0? Are you getting 0?
No, sir. We got minus 15.
Minus
Sir, we
15.
got minus 15, sir.
Minus
Yes, sir.
15. Give me a moment. 25x minus 10 into x minus 0.75 plus 20. 25x minus 10 into x minus 0.75 plus 20 minus 15x minus 2 minus 57.5. 25x 10x 0.5 plus 20 minus 57.5. How will you get how much you're getting? How much you're getting? At point how much? 7.5, yeah? 0 we should get, right? Let me check. I have done already this problem. I am getting 0. How much are you getting? Minus 15 you are getting, right? Okay. Give me a moment. X equal to 1.5. 25x. 25x is positive. Minus 57.5 minus 10 into x minus 0.75 plus 20 plus 20 minus 15 into x minus 2. Okay. See, this is minus 15 into x minus 2. It's minus 15 into minus 0.5. Kindly check it. Minus 15 into minus 0.5, that is. Even I did the same mistake. You also did the same mistake. Okay, got it? Got it? This is 1.5 minus 2, which will be equal to minus 0.5. You have done this mistake. right? Check it out. Okay. Now, shear force is 0 within the region 1.5 to 2.5. Shear force is 0. From this point, it will drop. There is no load. It will drop like this and remains constant 0 like this. Remains constant 0 like this. 0 like this. 0. You should indicate the magnitude of body state. Bending moment. Bending moment. It is 0 and 0, and it is linear. Linear in the sense, do you have any terminal? Is linear, there is 0 only. I can write it 0 like this. Ending moment is 0 toward the length. It is E to F. This is constant. This is linear. This is constant. This is constant. This is linear. 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 This is linear. This will be parabolic. This is constant. This will be linear. This is how we have to solve the problem. Okay, solid 20 mark problem. Concentrated and solid. If you understood this problem, all the problems are almost same. All the problems are almost same, and it may take some time for me to solve. Like this only, it will take easy problems you can solve. But this type of problems, still complicated problems, will take 2 classes continuously. All the problems are same like this. Starting from this point, from you should write the sketch. We should write the sketch like this. Find the reaction force. Each and every segment, you should pass a section and then find this shear force. Bending moment diagram. If there is a shear force, if there is a constant load, like this is constant load. This is no load condition. This is constant load. This is UDL. Then the external will come into picture for UDL. Then you should find at the 2 locations the shear force. Similarly, you should take for all the section. We should stop. Okay, I'll stop at this point. Any difficulty? As soon as we go on, if you practice the problems which I have solved, only 8 or 9 problems, more than sufficient you can solve. The way which I have solved. You should not take any other alternative. You'll go wrong. You'll go wrong with the same convention. They will take left of A, right of D, left of D, right of D, which will not. I don't think that is suitable. Okay, I'll stop at this point. Any doubts you can ask. Thank you.